So in this problem, we need to determine the equation of a parabola whose focus is at the point 1, 1 and tangent at the vertex is x plus y equals to 1. Let us begin. Let's try to understand the problem graphically first. So here we have a straight line, and on this line we're going to consider 2 points. One of the point is going to represent the vertex of the parabola, and the other point is going to be the focus of the parabola with coordinates 1, 1. Now by definition, any line on which the vertex and the focus lie is going to be referred to as the axis of the parabola. So here we have the parabola with its vertex at V. Now it's also given here that the equation of the tangent at the vertex is x plus y. So here we have the tangent to the vertex with the equation x plus y minus 1 equals to 0. Fine. Now this tangent is going to be perpendicular to the axis of the parabola. Now with this information we need to find out the equation of a parabola. Now to find out the equation of a parabola we need two information. One is the coordinates of the focus, so that's given to us, and the other information that we need is the directrix. So to define the directrix, we're going to consider another point on the axis. Let's call it point A with the coordinates a, b. Now point A has been chosen in a way such that its distance from the vertex is the same as the distance of the focus from the vertex. That means these two distances are of equal length. Now through this point A, we're going to pass a line which is going to be perpendicular to the axis of the parabola. So here we have the directrix. Now the directrix is parallel to the tangent at the vertex. Now how do we determine the equation of the directrix? To determine the equation of the directrix, we need the slope of the directrix, and we also need the coordinate of the point A through which the directrix line passes. Okay, so let's go step by step. First we'll try to find out the coordinates of point V. Once we have the coordinates of point B, we'll come to the next step of finding out the coordinates of A. So to find out the coordinates of V, so here what we'll do, we have the equation of the tangent line, that's x plus y minus 1 equals to 0. If we can find out the equation of the axis line, then the intersection of the axis line and the tangent line is going to give us the coordinates of the vertex V. So let's start with the equation of the tangent line. So here we have x plus y minus 1 equals to 0. We're going to rewrite the terms to get y equals to negative x plus 1. The reason why we're writing in this fashion, because we are going to compare it with the slope intercept form of a line y equals to mx plus c, where m is going to represent the slope. Now here, if we compare, we see that the slope is going to be equals to negative 1. So now we have the slope of the tangent line. Now from the properties of straight lines, we know that two lines that are perpendicular to each other, then the product of their slope is always going to be negative 1. Meaning, let's say we're going to call it m1. Let's say m1 equals to negative 1. This is going to be the slope of the tangent line. So now that we have the slope of the tangent line, we're going to assume the slope of the axis line to be m2. Now we can take the product of m1 and m2. So by definition it will be negative 1, which means that m2 will be equals to negative 1 over m1, which will be equals to positive 1. Now that means the slope of the axis line is m2. Now we can find out the equation of the axis line as well, because the line passes through the point 1, 1, which is the focus of the parabola. Here we are going to use the fact that any line that passes through the point x1, y1 having a slope of m, its equation will be given by y minus y1 equals to the slope multiplied to x minus x1. Therefore, we have the equation of the axis is now going to be, so it's passing through the point f1, 1 and the slope is m2, positive 1. So equation will be y minus 1 equals to 1 multiplied to x minus 1. This means that y will be equals to x. So this is the equation of the axis line. So let's call it, let's name this as equation number 1, and this is equation number 2. So solving equation 1 and 2, we can find out the coordinates of the vertex. So we will get x equals to 1/2 and y equals to 1/2. So that means the coordinates of the vertex is going to be 1/2, 1/2. Now that we have the coordinates of the vertex of the parabola, we can easily find out the coordinates of A. That's because V is the midpoint of the line segment joining A and F. That simply means that we can use the midpoint formula to define the coordinates of the vertex. So what we'll do, we'll take the x coordinate of point A, add it to the x coordinate of the focus, divided by 2. And for the y coordinate, we take the y coordinate of A, add it to the y coordinate of F, divided by 2. And this will be equals to the coordinate of the vertex. So that's 1/2, 1/2. So here we have defined the coordinates on the left hand side by using the midpoint formula, and 1/2, 1/2, that is the value that we obtain by solving the equation of the tangent line and the axis line. This means that we can equate them. So A plus 1/2 will be equals to 1/2, and B plus 1/2, so that will be equals to 1/2. And solving for A and B, we get A equals to 0 and B equals to 0. So that means the coordinates of point A and B, coordinates of point A, which will be 0, 0. Or we can say that the directrix is passing through the origin. Now we have the directrix line passing through the origin. Now to find out the equation of the directrix, we need its slope. Now the slope of the directrix line, that will be exactly the same as the slope of the tangent line, because they are parallel to each other, and we have already obtained the slope of the tangent line, so that's equals to -1. So that means the equation of the directrix will be y minus y1. So y1 will correspond to the y coordinate of point A. This will be equals to -1 times x minus x1. So x1 is 0. So this implies y equals to -x. Or we can say x plus y equals to 0 is going to be the equation of the directrix. So now we have the equation of the directrix, we have the coordinates of the focus, we have all that we need to obtain the equation of the parabola. So let us begin. So here we have the directrix, x plus y equals to 0, and the coordinate of the focus 1, 1. To find out the equation of the parabola, we're going to consider a point P with the coordinates x, y. P is going to be the locus of the parabola. So what we'll do, we'll join point P and point F. And we're going to drop a perpendicular from point P on the directrix line. Let's say the perpendicular line meets the directrix at M. So by definition of a parabola, PF is equals to PM. Now our goal will be to find out the equation of the parabola using this relation. We can find out PF because we have the coordinates of the endpoint. All we have to do is use the distance formula. We'll take the square root. Underneath the square root, we take the difference of the x coordinate, which is x minus 1, square this value and add it to the difference of the y coordinate, so y minus 1 whole square. This will be equals to PM. So PM is the perpendicular distance of point P from the directrix line. This is a standard formula for obtaining the perpendicular distance. We'll take the absolute value, and inside the absolute value, we have to consider a ratio. So in the numerator, we'll start with the coefficient of x of the directrix line. So that's 1. 1 will get multiplied with the x coordinate of point P. So we have 1 times x. Added to coefficient of y of the straight line, that's 1. 1 gets multiplied to the y coordinate of point P. And we also have to add the constant term of the directrix line, but there's no constant term here, so it will be simply 0. Divided by the square root of, we have to take the sum of the squares of the coefficient of x and y. So that's 1 squared plus 1 squared. So that's going to give us the square root of x minus 1 whole squared plus y minus 1 whole squared equals to the absolute value of x plus y divided by the square root of 2. What we'll do, we'll square both sides to get x minus 1 whole squared plus y minus 1 whole squared equals to x plus y whole squared divided by 2. So we can cross multiply with 2 to get 2 minus x1 whole squared plus 2 times y minus 1 whole squared equals to x plus y whole squared. So we can expand x minus 1 whole squared, y minus 1 whole squared, as well as x plus 1 whole squared to get the final result as x squared plus y squared minus 2xy minus 4x minus 4y plus 4 equals to 0. So this is the equation of the parabola.